Hello and welcome to this short video about 3D trig. Now when we're dealing with 3D trig we need to be able to visualise the shapes quite well, and what can help is to use the room that you're in, imagining the wall is a plane, the corner of the room is one of the vertices and so on. In this question I need to find the angle that AH, so that means the line AH makes with the plane EFGH. So that's the bottom, that plane there. Now to help me, what I'm always going to do is draw out a right angled triangle. Now the right angled triangle here is going right across the middle of it like that. For the right angle you always want to have a vertical plane meeting a horizontal plane. Now what I'm going to do is draw out my right angled triangle outside of the main diagram. I'm going to label up the corners so I don't get confused with what's where. I know that AF is 8 centimetres, that's on the diagram, but I don't know the size of FH yet. FH, using Pythagoras' theorem, is going to be the square root of 17 squared plus 5 squared. So if you notice, I've got a right angled triangle here going from H to G to F. So that side length there is the square root of 314. Now it's just normal SOHCAHTOA. I need to find this angle in here, because that's the angle that AH makes with the plane. I'm going to use my normal rules for SOHCAHTOA. Let's label it up. That's the opposite, that's the adjacent, and that's the hypotenuse. I know that the adjacent and the hypotenuse, the adjacent and the opposite, I don't care about the hypotenuse, so it's going to be a tan question. So tan theta is 8 over root 314, so theta is the inverse tan of 8 over root 314, which is 24.3 degrees. So we have another question here. They've already drawn one of the lines in for me this time. We want to find the length of BC. So I need this one here. The triangle that I need is this. Because I had to use FC. So you can imagine it's going diagonally across the room, cutting it in half. Again, let's draw out the right angled triangle. So that's B, that's F, and that's C. Labelling your corners is really key here. It really does make it easier. Now I know that FC is 16, and I need to find BC. If we look up at the diagram here, I've got another intermediate triangle here. So my green triangle there is 6 by 8. So that side there is the square root of 6 squared plus 8 squared, which is 10. So now I'm sure we can see this is just Pythagoras' theorem. The length BC is going to be the square root of 16 squared minus 10 squared, which is the square root of 156, which is 12.5 to 3 significant figures. Now what I need to find next is the size of the angle between FC and the plane ABGF. Now luckily this is the same as the triangle I've already found. This is this angle in here. So we imagine what's going on. The line FC is cutting right across the centre of the room, and it's meeting this wall, if you like, on the left hand side. So we can use the same triangle, fortunately. So I know that's 16 and that's 10, because there's my F, my B and my C. This is the angle that I want. I'm using the angles the side lengths that they gave me in the question rather than the one I just found out, because it's more just basically in case I made a mistake on BC. So again, we'll use SOHCAHTOA. This side here is the opposite, the adjacent and the hypotenuse. It's the opposite that I don't care about this time. So I know that cos of my angle is 10 over 16. So my angle is the inverse cos of 10 over 16, which is 51.3 degrees. So when you're doing these types of questions, the key things to look out for Find a right angled triangle. And remember, for the right angle you're going to be finding vertical and horizontal planes. Draw out the triangle separately from the main diagram and look for places where you need to use Pythagoras' theorem to find a missing side length. I hope that helps. Thanks very much.